In this lesson, we're going to work through the properties of logarithms. So there are a couple of properties, some that we've already reviewed and some that we have not. So for the first one, it's a log base b, so that doesn't matter what the base is, of 1 that is equal to 0. So that whatever the base is, if you're taking the log of 1, then it's just 0. Or if you have a log base b of b, that'll equal 1, that property we already worked on. And this next, remember, because the exponent's just 1, so if the base is the same as what you're taking the log of, the answer is just the exponent. For the third one, again, we've already worked on this property. Log base b of b to the x power is just equal to x. And then number 4, it's kind of a reverse of the one that we just wrote. If you have the base of an exponential and your exponent is a log base b, it's a b up there, of x, the answer is just x. Now, just keep in mind that the x has to be bigger than 0, so you can't take the log of a negative number because it's undefined. The number 5, this starts your 3 basic ones that we typically use. Really, it's only the 3 that you need to know. So the first one is called the product property, and that's log base b of m times n. So if you're multiplying two numbers or two variables, or a number and a variable together, you can expand that. So on the left is the condensed side, what I just wrote, and on the right, in the expanded form, we write log base b of m plus log base b of n. So if you have multiplication, then the product property tells you can expand it out, and you would put a plus sign there. Number 6, where there's multiplication, there has to be division, so this one's your quotient rule. So log base b of m divided by n, and that would be log base b of m minus log base b of n. So you subtract what you're dividing. And then the last property is called your power rule, and that would be log base b of m to some power p. Again, it doesn't matter what that number is. It could be a variable. That means that if you have an exponent, then you would take that exponent and move it out in front as a coefficient, so it becomes p times the log base b of m. So right here I took the p and put it in front of the log, so right here. And then that just became m to the first. So let's take a look at some of these examples. It says apply the properties of logarithms to evaluate. Do not use a calculator. So again, some of these we've already kind of worked on, and some will be really quick, and again, this would be on a non-calculator part. So for number 1, we have a log base 15 of 1. Well, that's just property number 1. Log with any base of 1 is just equal to 0. So this answer for number 1 would just be 0. Number 2, a little bit tricky, and again, that's the square root. So I'm going to rewrite the square root here. Remember, the square root of some number is equal to x to the 1/2 power. Remember, that's an index of a 2, so that's why it's 1/2. The index always goes in the denominator. So if you have the cube root of a number, that is x to the 1/3. If you have, say, I'll do another example. Say you have the cube root of x squared, that would equal x to the 2/3. The index is always in the denominator. So for this number 2, I'm going to rewrite the square root as 27 to the 1/2 power. Zoom in a little bit. So let's see, a couple different properties you can use here. You can use the product property or exponent, the power one. I'm going to rewrite the number 27. That's going to be my next step. Again, it's not the only way of doing it. It's just the way that I'm going to do it. So I'm going to rewrite 27 as 3 to the 3rd power, because 3 cubed is 27. And then I'm just going to carry that 1/2 down as an exponent. You may have to think back to properties of exponents. If you have exponents that look like this, you're going to multiply them. So 3 times 1/2. 3 times 1/2 is just 3 halves. So we keep the base 3. So I kept that 3, that was a base, and I multiplied these exponents. And I got 3 over 2. Just a little refresher, when you multiply 3 times 1/2, remember that's 3 over 1. So you just multiply straight across. So 3 times 1 over 1 times 2. So that's where the 3 halves came from. And then here we have a log base 3 of 3 to the 3 halves, which we've already discussed this property. This one would just be 3 halves as your answer. Number 3, again, another one that we've talked about before. Here in the natural log, we can rewrite as a log base e. So that was just the ln part. And then this part right here, the e to the 16th, I'm just going to write down next to it. So we have a log base e of e to the 16th, which is just simply 16. Number 4. Oh, number 4 is off to the right. So number 4 is the property up at the top. Let's see, which one is that? That is property number 4. So we have the base of an exponential, which is 5. We have a base of a log that's up here in the exponent, and that's 5. So your answer is just simply the 12 that's in the exponent. That would just be your answer. Number 5. I put this one on here because a lot of times you forget that the base of a common log is 10. So if it doesn't have an exponent or a base, then it is a base of 10. So we have a log base 10 of 10 to the x minus 2. So your answer is just x minus 2. In problem number 6, again, we have in the exponent, I'm just going to rewrite the natural log, that ln, as a log base e. And then the 4x I'm just going to carry down next to that. So now, again, this is property number 4, that same property that we just used. I think it was problem number 4. So you have an e, and you have a base of e in the exponent, so your answer is just 4x. So for number 7, again, it's pretty similar to that property number 4. It looks a little bit different, and there's going to be a little bit of work we have to do ahead of time. So up here in the exponents, we have something that looks like it might be property number 4, but a little bit off because I have that 3 that's in front of the log. So what I'm going to do is I'm just going to write that exponent down, and remember that 3 that's in front of the log, we can use a property, the power property, and move it up as an exponent. So I'm going to take the 3 that is in front of the log, and I'm going to put it up here as an exponent of the 4. So 4 to the 3rd power I can actually evaluate. So we'd have 8 log base 8 of 64. 4 times 4 times 4. And now that's the property where if you have the base of your exponent and the base of the log are the same, your answer is just 64 in this case. And again, number 8, again, pretty similar. You're going to take the 4 and move it up as an exponent. So you'd have 2 to the 4th power, and 2 to the 4th power is 16. And remember that if you have a natural log, that's a log base e. So if you need to, you can rewrite the ln over here as a log base e of 16. So again, that same property, the base of the exponent is the base of the log, so 16 is your final answer. So now moving on to expanding. When we expand means to make bigger, so we're going to start here with one log base 3, and we have an x times a y times a z. So we're multiplying 3 variables together. So when we expand it, we're going to make it bigger. We're going to have multiple logs in this case. So multiplication is using your product property, which means that you expand it out. You're going to write log base 3 of x plus log base 3 of y plus log base 3 of z. And then that would be, for this problem, as far as you can go with the properties of logs. Properties of logs are used a lot when you get to calculus, so if you plan on taking calculus in the future, you're going to be really need these properties to help you get through some of the problems. Number 10. Number 10, I have a couple things that I have going on here. I see that I have division, so I'm going to use my quotient property. So I'm going to do that first and expand it, and when we use the quotient property, I'm going to take log base 4 of x to the 4th, that's the numerator, and I'm going to subtract log base 4 of y squared. So the first step is to use your quotient rule, and then after that I have these exponents, and when we expand it, we're going to move the exponents using your power property, which means you're going to take the 2 and move it in front of the log that it's with. And the 4 you're going to move in front of its log. So this would be 4 log base 4 of x minus 2 log base 4 of y. Now a lot of this, after you start doing a couple problems, you'll be able to do multiple steps, and that's fine. But if you still need to take it step by step and one property at a time, that's perfectly fine too. So for number 11, I see here that I have a square root of v. Well, none of my properties at the top have anything about square roots in them. So the first thing I'm going to do in this problem is rewrite the square root using exponents, what we did up above. So u to the second is perfectly fine. It's that v that we need to change. So if you have a square root, that's the same thing as the 1/2 power. You do need to know that. Make sure that you kind of work through that, and if you have questions, make sure that you ask me. So now I'm going to expand this. I have multiplication, u squared times v to the 1/2. So I'm going to use my power, or my product property, and that means that I'm going to expand it out using addition. So you have log base b of u squared plus log base b of v to the 1/2. And just as in the previous problem, I'm going to take these exponents and move them in front of the logs. So you'll have 2 times the log base b of u plus 1/2 log base b of v. And that would be as far as that problem goes. For number 12, we're going to be using pretty much the last three properties. So up in the numerator here, I have multiplications because we have an f to the negative second times d to the first, so that's multiplication, so I'm going to expand that out using addition. And then I also have down here, I have division, so I'm going to use my quotient property, and I also have these powers that I'm going to move in front. So the first thing I'm going to do is I'm going to separate out using the quotient property. Again, you can use multiple steps in a row if you like. I'm not. I'm going to take it step by step. So I'm going to take the log base 2 of the numerator, and I'm going to subtract log base 2 of n to the 8th. So now that's the first, is using your quotient. And the next one is, here I have my multiplication, so I'm going to use my product property. So I'm going to expand that part out using addition. So log base 2 of f to the negative second plus log base 2 of d to the first. And I'm just going to carry down that minus log base 2 of n to the 8th. And then the last step here is to take my exponents and move them in front of the logs. So you'll have negative 2 log base 2 of f plus log base 2 of d minus 8 log base 2 of n. Number 13 is a doozy. Number 13, you will see there's a couple on your accelerated math that are pretty similar to number 13. So you might want to highlight it and star it, maybe bookmark it, write it down on another piece of paper or something, because you will see it. So the first thing I need to do is rewrite that seventh root. Remember, if you have the seventh root, you can rewrite that as the seventh, or the 1/7 power. So you'll have everything inside to the 1/7 power. So you'll have x to the second, y to the 14th, and then in the denominator there, z to the 4th. And then the next step, again, properties of exponents, I'm going to take this 1/7 and multiply it by all of my exponents. So we will have log base b. And then here, when I multiply 2 times 1/7, I'll have 2/7. And then 14 times 1/7 is 2. And then in the denominator, when I multiply that exponent 4 by 1/7, I'll get 1/4. So now I just have all these exponents, and we have a property of logs that allows us to be able to expand out those exponents. So again, just in the previous problem, we have our multiplication and we have division, and we have our exponents. So let's see, the first thing I'm going to do is expand out using my quotient property, which means that I'm going to keep my numerator together for right now. So I'm going to keep it log base b of x to the 2/7 and y to the second. But I'm going to subtract out log base b of z to the 4/7. That's using your quotient property. And now I'm going to expand out using my product property. Log base b of x to the 2/7. Remember, if it's product, we're going to add log base b of y to the second. And I'm just, again, going to carry down that log base b of z to the 4/7. And then one final step is to take your exponents, the 2/7, the 2, and the 4/7, and move them in front. So you'd have 2/7 log base b of x plus 2 log base b of y minus 4/7 log base b of z. For number 14, also one that I put on your accelerated math, I put on here because you will see it, so 14 and 15 are pretty similar. For this problem, we're given that the log base c of 2 is equal to, and they give us a number, an approximation 0.431. We don't really know what the base is, nor do we really need to at this point. And we know log base c of 3 is 0.683, and the log base c of 5 is equal to 1. Again, that varies, and then this is just given information. But the thing that we need to know is that we're given log base c of 5 divided by 12. Now I can use my product property, or my quotient property, and do log base c of 5 because I know what that is, and then minus log base c of 12. But the problem we have is, in our given information, 12, we were only given log base c of 2 and 3 and 5. So we didn't know anything about 12. So what we have to do here is we have to rewrite the number 12 so we get numbers that we can use. So I'm going to rewrite it as 2 times 2 times 3, because I needed to use only 2's and 3's. So 2 times 2 is 4, times 3 is 12. So 2 times 2 times 3. And now I can use my properties. So we'll have log base c of 5 minus, and then see how in the denominator here, 2, 2, and 3 are all in the denominator. So that means that when we use our quotient property, we're going to have subtraction because they're all in the denominator. So we'll have log base c of 2 minus log base c of 2 minus log base c of 3. Now I understand that they're all being multiplied, and maybe you're wondering, well, we usually with multiplication we use division, or we use addition, which is perfectly fine. Let me give you the middle step there, that maybe if you're uncertain of how I did that. what I did was I subtracted log base c of 2 plus log base c of 2 plus log base c of 3. So essentially what I did was I had already distributed this negative. So a minus times the first one, a minus times the second one, and a minus times the third term. So it essentially is all subtraction. I just subtract it right away if I know it's in the denominator. Just saves me a little bit of time. And all of these values we know because they were given to us in the actual problem. So I know log base c of 5 is 1.000, and log base c of 2 is 0.431. And I'll write that twice because I'm subtracting it twice. And then log base c of 3 was 0.683. And then you can put that in your calculator, and let's see what we get. When I put that in my calculator, I ended up with negative 0.454, or 545 for your final answer. The next one is pretty similar, same idea. For number 15, again, pretty similar. They give us log base z of 7 as an approximation, and 11 is a number also. And they want us to find log base z of 77. So 77 is not 7 nor 11. So what it is we can break the 77 down and rewrite it. So it's log base z of 7 times 11. 7 times 11 is 77, which is nice because I know something about 7. The log base z is 7, and I know something about log base z of 11. And I know that I can use properties of logs. So we'll do log base z of 7, it's your product property, so I'm going to add the log base z of 11. And both of these numbers are given to us in the problem. So log base z of 7 is 0.886, and I'll add on 1.091. And you add those in your calculator. Let me take a minute and add mine, and then make sure you're practicing too. When I added those together, I got 1.977. And condensing. Condensing is just using the properties in the reverse direction. So instead of multiple logs, in the end I'm going to have just a single log. So we're going to work backwards from what we were working on. So in number 16, I'm going to take my coefficients here, and I'm going to move them up as exponents. So this will be log base 3 of x to the 5th minus log base 3 of b to the 4th plus log base 3 of y. First thing I'm going to do is condense my first two. So I like to go left to right. I find it easier. Let me zoom in so I have a little bit more to work with. So it is subtraction, so the first step here when I condense these two would be log base 3, and I'm going to divide x to the 5th by b to the 4th. So once we have that, now we have two logs that are being added, so you're going to condense those down by using the product property. So log base 3, and you're going to multiply x to the 5th, b to the 4th, times y. Remember, when you multiply by y, you're essentially multiplying by y over 1. So we're going to multiply these two fractions to get just one single fraction. So you'll have x to the 5th times y divided by b to the 4th. Now again, you can figure it out if you have you only have one minus sign, so the only one in the denominator would be the b. And then see here with the y, we have a plus sign. That means that it's going to be in the numerator. So if it has a minus sign, it's going to be in the denominator. If it has a plus sign, it'll be in the numerator. Number 17, again, same idea. I'm going to take my exponents and move them up as powers. So you have log base b of x cubed plus log base b of 2x plus 1 minus log base b of 4 squared. So I'm going to condense my first two logs together using my product property. So log base b, and I'm going to multiply x cubed times 2x plus 1. You can multiply that out if you like. And then I'm going to just bring down the last log, and I'm going to go ahead and evaluate the 4 squared. So 4 squared is just 16. And then I'll condense down one more time. I have two logs. I'm going to condense them down into one. And then it is subtraction, so that means that I'm going to divide. So I'll have x cubed 2x plus 1 over 16. Number 18 involves natural logs, which have the same exact properties as regular logarithms, because they are logarithms. Again, the first step I'm going to do is take the exponent, or the coefficients, the 3 and the 8, and move them up as exponents. So you have the natural log of 7 minus the natural log of t to the third plus the natural log of v to the eighth. And just like the other problems, I'm going to condense my first two logs together first. And since it's subtraction, I'm going to use my quotient property, which means that I'm going to divide 7 by t cubed. And then the last step I'm going to do is combine my two logs now back into one, and it is addition, so that's my product property. So that's the natural log of 7t cubed times v to the eighth. And just like in the problem above, this is v to the 8 over 1. So when we combine that fraction and multiply them together, you'll get the natural log of 7v to the 8th divided by t to the third. Now t to the third, again, what we had discussed earlier, t to the third is in the denominator, and if you look in the original problem, the only one that has a minus sign, that has a negative, is the t. So the 7 is in the numerator because it's positive, the natural log is positive, and the v has a positive 8 natural log in front of it, so that would be also in the numerator. And the last of the condensing, again, pretty similar to all the other ones. I'm going to take my exponents, move them up. So I have the natural log of x to the 1/2 power plus the natural log of y to the 1/2 power minus the natural log of 4. The first two have an addition sign, so I'm going to use my product property. So I'm going to multiply y to the 1/2 and x to the 1/2. Remember, the 1/2 power is the same thing as the square root. So I'm going to rewrite that as just the square root of xy. I can do that and put them under the same square root, and only because they both have the 1/2 power. I couldn't do that if only the x had a 1/2. If only the x had a 1/2, then only the x would be in a square root. If only the y had had a 1/2, then only the y would be in a square root. If they were not both in the square root, then, or to the 1/2 power, they would both not be in the square root. And then bring together these two logarithms. It's subtraction, so I'm going to use my quotient property, which means I'm going to divide the square root of xy by 4. It is nice to put parentheses around after the natural log or the log or brackets or something to indicate that they all stay together. And the last thing we're going to do is the change of base formula. The change of base formula we use because not all calculators you can change bases. They're all base 10, your graphing calculators, your scientific calculators. So you can't evaluate like a log base 6 because it's not base 10. Your calculator only does base 10. So the way that we do this is we take the log of m and you divide it by the log of b. The way that you can remember it is the base, the b, is in the basement of the denominator. So you always divide by the log of whatever the base is. So here in number 20, use the change of base formula to evaluate log base 4 of 17. Again, you can't just type it in your calculator. I think you can do it just in Desmos, but remember you can't use Desmos on your test. So you might want to make sure that you know how to type it in the graphing calculator or just a scientific calculator. So for this one, you're going to write log of 17, and it is base 10 now. And I'm going to divide that by the log of 4. Remember, the base is in the basement. And then you just type in log of 17 divided by log of 4. Now when you type this in your calculator, make sure that you write log. The calculator opens up a parenthesis when you type in log. Make sure you close that parenthesis after the 17 before you divide it by the log of 4. So go ahead and type that in the calculator and see what you get. When you type it in the calculator, you should get approximately 2.04 when that's typed in. Now if you're using Desmos, you find the log button in function. It's on the far right underneath the graph. So functions, and then you'll have to click the tab that says miscellaneous, and the log is in the miscellaneous section. And then number 21, same idea, change a base. So for this one it would be log of 34 divided by the log of 7, and you type that in the calculator. Once you type that in the calculator, you should get 1.81 approximately.